Okay, good morning, everyone. Today I will go over some problems you may have on your tests on Thursday. These are the type of problems I had when I was in high school, and they're good problems. They'll help you increase your skill in working with radicals, okay? So these problems will involve finding values of A, B, or C for the given problems. And so, for example, for problem number one here, I have the cube root of AB. What was AB that gave me 2x raised to the third times the cube root of 7? What was the values of A and B? Well, this requires you to work in reverse here. Okay, so, and when I mean work in reverse, I see I have 2 here, and so because I have an index of 3, then I'll just go, well, so 2 to the third, I have an index of 3. And then again, I have x to the third here, and I have an index of 3, so when I go x to the third times to the third, or 3 times 3, that will give me x to the ninth. And then what I have left over here then, is 7. Okay, so if I multiply all of that out, that will be 8 times 7 times x to the ninth. And so that means then that A was 56 and B was x to the ninth. Okay, so A was 56 and B was x to the ninth. All right. Again, I'm just working in reverse. All right, and so if I go to simplify that, you'll see what I got. So if I have the cube root of 56x to the ninth, that will be the cube root of 8 times x to the ninth, 3. The largest multiple of 3 that's less than 9, that would be 9, and then what's left over would be 7. 7 times 8 gives me 56, and you'll see that gives me the cube root of 8 is 2, and 9 divided by 3 is 3, and then the cube root of 7, so it checks out. Again, we're just working in reverse here. Okay, let's look at another one here. So again, I see I'm working with, so I want to find values this time of A, B, and C. I just don't have A, B, I have A, B, and C. So I want to find values of A, B, and C. That gave me 2xy squared, the cube root of xy squared. So again, I will work in reverse. So again, I have index 2, so in here I have 2, so what was inside or underneath the radical would have been 2 to the third. And here I have an 1, x raised to the 1, and 1 times 3 is 3, and so that would be x to the third. And then I have a 2 for y squared, so y squared, so 2 times 3 would have been 6, so y is 6, so that would have been y to the 6. And then what's left over then in the radical was xy squared. Okay, so I'll have 2 to the third is 8, x cubed times x, and then times y is 6 times y squared. And so that would give me 8x to the fourth, y to the 6. Oops, 8. 6 plus 2 is 8. 3 plus 1 is, okay. So then A would have been 8, B would have been x to the fourth, and then C would have been y to the eighth. And I'll just check here. So if I simplify that, so if I have the cube root of 8x to the fourth, y to the eighth, let's see here, that would be the cube root of 8x to the third, and then y to the 6, 3 times 2 is, and then what would have been left over is x and y squared. And that would have given me 2x y to the second, which is what I had, times the cube root of xy squared. So again, we're just working in reverse. Working in reverse here. All right, so let's do the last one. All right, this involves a radical. Okay, so I'm looking for the value of A. I'm looking for the value of A that would have given me 5x squared times the square root of 6 all over 3. Well, probably the easiest thing to do, I'll just break it up. So maybe I'll have my numerator is ax to the 4th, and then my denominator is the square root of 3. Okay, well, I see that x to the 4th is what I had because I got x squared, so my index is 2. Okay, but I have to find a. Well, when I take a look, here, I have 5. Again, my index is 2. My index is 2 there. So if I take 5 squared, okay, so, which would give me 25, so I know that this would have been, so if I take 5 and squared, because I have 5 here, and I'm multiplying that by my index, 5 squared, that would have been 25, 25, and then x to the 4th. I was given x to the 4th. Okay. And all over, let's see here, the square root of 3, which is just 3 raised to the 1/2. Well, when I multiplied or rationalized my denominator, I would have multiplied by 3 raised to the 1/2. 1/2 plus 1/2. So 3 raised to 1/2 times 3 raised to 1/2. But then when I simplified this here, I would have gotten the square root of 25 is 5, and then x squared times the square root of what? Times the square root of 3. Because 3 raised to the 1/2. 3 raised to the 1/2. Oops. 3 raised to the 1/2 is the square root of 3. So then this number here, this what, if you will, this question mark, well, that would have had to have been 2, because I got 6 here. Okay, so that would have had to have been 2. So that question mark would have had to have been 2. Okay, so what I really had in my numerator then was I had the square root, so 25 times 2 times x to the 4th. Right, and so that would have been the square root of 50 x to the 4th. So a would have been 50 and divided by the square root of 3. Yeah, so a would have been 50. So, and again, if I simplify this, you'll see, so this is going to be the square root of 25 x to the 4th times the square root of 2, all divided by the square root of 3. And actually, the easiest thing to do here would have been just to, we didn't even have to write this as a exponent. I could have just multiplied by the square root of 3. Yeah, and so then that would have given me 5x squared, square root of 6 over 3, which is what I had. 5x squared times the square root of 6 over 3. So I didn't even have to multiply. I mean, I could have just left all of this, the square root of 3. So, because I would have had to multiply by the square root of 3. But then 25x to the 4th would have given me a 5x squared, and then I would have been asking myself, then what would have been left over to have gotten 6, which would have been 2. All right, so that meant then underneath the radical would have been 25 times 2x to the 4th. All right, now let's go on to applications. So here, if you, during an accident scene, police, they try and investigate the accident scene, and they're trying to determine how fast the driver was driving. And radical functions are a good application of that. So here the speed s in miles per hour that a car is traveling when it goes into a skid can be estimated by using the formula s is equal to 30 times f times d, where f is the coefficient of friction and d is the length of the skid marks in feet. Okay, after an accident, a driver claims to have been traveling the speed limit of 45 miles per hour. The coefficient of friction under accident conditions was 0.7. Is the driver telling the truth about his speed? Explain. Okay, so we're trying to find his speed. All right, so I guess one way, so we're saying if the driver had been traveling 45 miles per hour, when we go to investigate this, okay, when we go to investigate this, we want to figure out the distance. Or take a look at the skid marks, the distance of the skid marks, and the distance of the skid marks will actually tell us how fast the driver was going. Yeah, they actually take a look at the skid marks. Okay, so use the formula to determine the greatest possible length of the driver's skid marks if he were traveling 45 miles per hour. Okay, so you set s is equal to 45. The coefficient of friction is 0.7, and we want to solve for d. So I have 45 equals 21 times d, so we square both sides, and we get 2025 equals 21d. We get d is equal to 96. Okay, so if the driver had been traveling 45 miles per hour, the skid marks would have been 96 feet. Okay, but when you take a look, but when you actually look at the skid marks here, they were 120 feet. 120 feet. So which means the driver would have been traveling greater than 45 miles per hour. So when the police are investigating an accident scene, that's what they're doing. They're looking at, they're looking at how long the skid marks were, and from the length of the skid marks, they're able to determine how fast a driver was going.